morning everybody. Department of EEE France Xavier Engineering College, Tirunelveli welcomes you all. Electrical and Electronics Engineering Department was started in the year of 2002. The department is functioning with two PG courses such as Power Electronics and Drives was started in the year 2011 and Power System Engineering was started in the year of 2013. We got recognized research center status from Anna University Chennai in the year 2017. And our department reaccredited by National Board of Accreditation, New Delhi from 2017. The department has a strong faculty strength who are committed and are specialized in various streams of electrical engineering. Also, we have DST, FIST supported Advanced Power Electronics and Drives Laboratory and National Instruments Powered LabVIEW Academy.
Good morning to all present here. It gives me immense pleasure to welcome you all on this seminar session. This webinar is hosted by the Department of EEE and the Department of Alumni Association on behalf of our Chairman, Dr.S.Sudalai Babu, our Managing Director, Dr. Arun Babu, and our General Manager Development, Dr. J. Kumar, and our beloved Principal, Dr. Ven Murugan, and Director of Alumni Association, Mr. Krishna Kumar, and our HOD, Dr. P. Annapandi. I welcome all the heads and faculties in various institutions and the participants and beloved alumni of FXEC. While getting delay, my hearty wishes to Dr.S.Sudalai Shunmugam, one of the best alumnus of FXEC. At present, he is working as an associate professor in the Department of EEE in BNM Institute of Technology, Bangalore. Till now, he published 12 research papers. He is motivated and highly professional electrical engineer with close to 5 years of industry experience and 3 years of teaching experience. He possesses rich knowledge and experience in power engineering and problems and optimization problem, etc. At present, he is working as associate professor in BNM Institute of Technology, Bangalore. He had experience of 2 years and 1 month. At past, he worked as a senior research fellow in CBRI, Bangalore. He had an experience of 4 years and 7 months. And he working as a assistant professor in 11 months in National Engineering College, Kovilpatti. He did many projects. I mentioned some of his project clients are Central Power Research Institute, Bangalore, L&T, Power Grid Corporation of India Limited, Delhi Metro Rail Corporation Limited of Network. He did 2 patents. Both are belongs to Indian product patent. One is under the topic of specially designed porcelain long rod insulator for highly contaminated environment, and next area is improved insulator for use in high electrical equipments. Without delay, I would like to welcome the dignitaries. Now I hand over the session to Dr. S. Sudalai to proceed the seminar. Sir?
Yeah, please. Good evening, everyone. I believe the slide is visible to everyone.
Yes, sir.
All right. Small correction. I belong to EEE department, not EC department. Other than that, it's a wonderful introduction. Thank you so much. Yeah. And it's the institute where I carried out research, Central Power Research Institute, CPRI. Anyway, let us start the session. I believe the slide is visible to everyone. Shall I move?
Yeah.
Okay. Since I'm in full screen mode, I can't able to see any chat messages from my end. And if at all any doubt is there, I request some of the faculty over there to take over and inform me whatever the doubts. I'll be glad to stop then and there and happy to explain to you. And if the screen is minimized or some other issue is there, please let me know. I have not carried out any session in this particular Google Meet. So if at all any as per the information I got from Professor Shunmugam, 70% of the participants belong to undergraduate, 20 belongs to either postgraduate or doing PhD, and 10% of the participants are PhD holders. So I'll be speaking the research opportunities from the undergraduate level. Eventually, I will elevate to postgraduate. And what are the present problems we are facing in the electrical power engineering domain? I'll be covering that step by step. If at all any doubt is there, kindly be vocal. You can ask anything and everything. I will try to do justice. Good evening, guys. So let us speak about what are the research opportunities available for power engineering, especially high voltage engineering, power system together forms power engineering problems right now. To be honest, we are in a if you are in the electrical domain right now is the interesting phase in the entire century where there is no only electrical problem, electronics problem are not there. Right now, we have a wonderful area where we can deal with power system, high voltage, dielectrics, everything. As electric engineer, and even as electric engineer, you can do data studies, how the data is communication, protocol has been made, how the substation being automated, and everything. So, as electric engineer, it's our duty to make sure that we have gained enough skill set while we are doing undergraduate program and apply that skill set, build on that particular level where you are at the postgraduate, and make sure that you are employable. It's more or less our duty nowadays. So why undergraduate research is very much important is you have to only by means of doing research you can understand what is happening in the field. The moment you started doing research or by reading more, particularly the moment you started to read more and more technical papers, particularly reports, your knowledge on the particular domain will start to expand. And the moment you started to do things, that's where the real growth happens. So I encourage all of the undergraduate students who are there to do actual research. What I mean actual research is try to understand what is happening in the field. I will tell you where to read, how to read, and everything in the process. Make sure that you are really keen on what you are studying in those 4 years. What is the area of interest which you are looking into. Make sure that you are in contact with the faculty who is teaching that subject. If that faculty is teaching or doing PhD, it's well and good. Go to them, contact them, ask for small PhD problem of their work. Take that work as your project. I believe in the final year you will do project. Before that also you try to do maybe a small project on that one. Make sure that you are a part of a active research work. And I believe that only by being a part of a active research work, you can make sure that you are really gaining something out of it. And the moment you started to work on a problem, eventually your skill will enhance. And the moment you add any additional skill set, it will be reflected in your CV and it will be giving an additional boost whenever your companies are coming to your campus. And most importantly, out of the 4 years what you are studying and keep on studying, you can make an actual contribution to the domain, not only to the domain and to the entire world. And if you ask what is the area where undergraduate student can do research, I would say anywhere and everywhere. The reason being, as an undergraduate student, everything what we have been taught in the class is very new, and if you have a bit of open mind, every subject is a new opportunity to do carry on. So there is a huge research work available right now in the Indian power system. I will speak about that in the very next slide soon. And before doing to the further slide, kindly have enough motivation when you are doing research. Especially, you have to believe that you are able to do research. Forget about the noises coming out. You just think about that it is possible from your end that you can make an actual contribution, and then the probability might come or might not come, but it's insane belief that will drive you to the success. I believe that this is the quote of Elon Musk, and it's really very close to research mindset. So how to when come back to the first slide, how to actually choose a research problem. uh, for example, how to choose a problem which is actually there in the Indian power system, how to know what is the problem in the power system. If you have those questions, the simple answer is kindly read. If you are an Indian, you can read Central Electrical Authority reports. In short form, those are called the CEA reports. Government of India has the duty to publish yearly what are the faults happened in the Indian power system, in which region it had happened, what is the cause of that region, what is the cause of that particular fault, and what are the steps taken to address those faults. This is a mandatory from the government of India, and yearly once they will publish Central Electric Authority report. Not only yearly once, there you can see multiple reports in the 3 months once also they will publish. Why I'm asking you to read these reports are the moment you start reading those reports, you will know that what is the problem happening in your area. If you belong to power system, then you will know what is the stability analysis happening. What is the stability problem Indian power system is facing this year. The moment these problems has been identified, what is the next step global R&D sector as well as Indian R&D sector they will do is they will form a task force. Task force, the main agenda is whatever the problem the utility has given. The moment I say utility, it means your CEA, Central Electricity Authority. The reason for any task force formation is to address the problem stated in the CEA reports. So it is imperative and it's a very much essential duty as a student to know what is the problem happening in your area and what is the active task force doing on it. The moment a task force formed, it means there is an actual problem in the system. At least up to that, you can ascertain yourself. And the next step is find what is the working group. What is normally a working group means scientists around the world, they will form the working group to address the problem which has been defined by CEA, that is Central Electricity Authority, as well as by the task force. You have to read a working group reports. The reason being, it will give the detailed analysis of the problem, when and where it has happened, why it has happened, how it has happened, what are the parameters which actually influences this problem, and what and when and where or how much our research should be focused towards simulation and hardware. These criteria, everything is available as a ready-bound material from working group reports. The moment you study one working group report, you will understand, for example, a flashover problem. If there is a flashover problem, there is a working group committee report by 2010. Twice it came. If you read those reports, every report is around 60 to 90 pages. It will completely solve the those who are doing research. They will be doing a thing called literature survey. They will be doing usually 6 months to 1 year. That is the general nominal time. If you read a report, SIGRE report or IEEE report or CA report, it will reduce the work to 1 month. Literally 1 month it will reduce. The reason being someone has already found the problem, they had made a task force, they had made a working group committee. So just by reading the working group committee, and every report in the working group is usually 50 to 200 pages roughly. The moment you read any 200-page document speaking about a single source of problem and what are the causes behind that, you will understand in-depth analysis what had happened, why it has happened, and in and out of that problem. So I believe this is one of the regular structure everywhere, IISc, CPRI, be it or NIT, IIT, everywhere this is the structure they research students in undergraduate level and postgraduate level will follow. I'm moving for the next slide. If at all any doubt is there, you can always ask. And there is a particular reading pattern you should follow. Don't directly go for a conference paper or a journal paper. I request all of you to study first reports, and if you are studying the reports, then go for magazines. The reason I am stressing on magazine is magazine deals not only with the technical problem, magazine deal with the manufacturing problem as well as with the utility problem. If you read any magazine article, be it IEEE Electrical Installation Magazine, that is nothing but EIM or Power Engineering Society PES, they will speak about the problem. They will speak about the problem faced by the utility. They will speak about the problem being faced by the consumer, and they also speaks about the problem faced by the manufacturer. So a same problem, three different perspective in a detailed manner you will get. And the magazine actually gives the real world application for you. The moment you read any magazine article, especially IEEE magazine article, it will give a clear picture of what is happening in all the three sectors. And it will give a general idea for you to where to focus on and how to focus on. And if you are comfortable with the magazine, then you can always go for a journal, and then you can move for PhD thesis, MSc thesis, that you can go. This is one of the order widely preferred when it comes to research. And where to develop the skills, how to develop the skill. For example, right now everything is about skill set. I have not included here Coursera or edX. I included the general research institutes where hands-on as well as software skills both are given. The training for both over programming skill is being taught to you, as well as they are giving enough hard work so that you can work on that. I'm including the institute of only that caliber. So there is a research institute, Central Power Research Institute. It's around 7 places in India. If you want to sell any power product, I repeat, if you want to sell any power engineering product in India, you need certification from them. Unless until you get certificate from them, you can't buy, you can't sell any power product in India. So that much big the organization is. They are conducting lot of skill development program, especially workshops for on various standards, various research techniques, and various software programs also. If you can't come to Bangalore or certain places in India, there is a National Power Training Research Institute right in Chennai only. In Chennai it is there, in Bangalore it is there. If you check on Google, you will know whether it is available in your state or not. Why I'm insisting on National Power Training Institute is Central Power Institute deal with utility manufacturers and everyone, whereas NPTI National Power Training Institute deals only with, most of the time 90% they deals with academia. That's you who are in the college. They are offering multiple programs for both faculty as well as for students. So any faculty who want to get trained on them, you can approach them. There is a year-long schedule. For by January only, they will upload in their webpage what are the skill development program they are going to conduct via online and offline, both. And you can also attend research summits. Usually, research summits will happen at NIT and IIT. Certain times IISc also will conduct. You find what is the research area you like to do that, and find the research summit. It is the primary duty to find in, if you have an area of interest, which institute is doing research on that area, or which scientist or researcher is doing that work, what is the hot topic or hot trend in that area. If you follow this particular skill set, it will be very easy for you to attain that goal. And there are a lot of fellowship available, especially for undergrad and grad, postgrad as well. There is an SRF JRF program available in IISc, IITs, NITs, and NCPRA as well. So if you completed undergraduate, if you want to do masters, you don't have to pay money. The government will pay money for you. I repeat, if you are an undergraduate, if you want to do masters, government will pay money for you roughly around 30,000, 25 to 30,000. They will sponsor your PG research as well. Government is having those facility and government is providing. Please search what is senior research fellowship, what is junior research fellowship, and suppose you are in a college, any undergraduate college in Tamil Nadu, and you want to do actual research, government labs are available, even including CPR. I am telling, government labs are available for undergraduate research work. They will allow, provided you contact them prior. If you are in the last term, you can't contact them in the last term. Contact them in the 7th semester only. Or if you want to do research in the 3rd year, contact them 6 months before. Mention the research you want to do. What are the equipment you need to access. Send a mail to them. If not immediately, within a month, you will definitely get a reply. I request all of you to go to places, see the things, handle the laboratories, simulation softwares, and understand the nuisance of the programs, how the process actually happening. This will make you an actual researcher. And there are various agencies available, including AACT. I have not included AACT here, but AACT also provides undergraduate and postgraduate funds. And there is SERB, Science and Engineering Research Board. I included a couple of pages for your understanding. Dolepages.com, the third one. Sorry, dolepages.com. That will give what is the funding available for undergraduate and postgraduate and PhD. And as a undergraduate student, if you want to do internship opportunity also available in dolpages.com. This is one of the page I just given for you. And there is a community called the Power Group community. If you are a electrical engineering person, if you are a electronics engineering person, and you want to know what is happening right now all over the globe, they had formed already from the University of North Dakota Power Globe community. Kindly look into that. What is Power Globe community? What is the how many scientists were there? What are the problems they are daily, day by day they are facing? And they will most of the time ask for researchers, undergraduate student, postgraduate, and internship also they are providing. Please look into those communities and web pages. And if you want to build a CV of world class, there is a couple of web pages. I just given only one. There is a web page called eurocv.com. You can look into that. Most of the universities in Europe, they want your CV in the Euro CV format only. Suppose you want to do masters abroad, they prefer your CV should be in Euro CV. The moment you see the subheadings in the Euro CV, you will know what is the skill set you should develop. Shall I move for the next slide? Okay.
Yes, sir.
Alright. If you want, I'll give a moment to copy down this. Just saying how to submit an article in national and international level. Better to start with a review article, then very much focused national or international conference. The reason I have given focused means make sure that whatever the area you are doing, you are submitting the article only on that highlighted domain conference. Suppose if you are doing a research in communication, make sure that you are publishing your paper where the communication technology is the theme of the conference. The reason I'm stressing is the moment you are submitting any article in international conference, most of the time international persons will come. It will be much helpful for you. It will be much helpful for you if those international persons see the article you are presenting, and if you get any contact or any input to build on your work. That's why usual process of submitting an article is start from a review article, possibly on national level, then move for a national and international conference, then eventually for a journal. The moment you follow the earlier steps I have mentioned, and if you follow this article submission process, more 80 to 90% success is possible, quite possible actually. So let me directly go for power engineering problem. Especially I'm going to deal with only with the outdoor insulation and a little bit on the indoor insulation problem. The time permits, I will cover the rest of the area. So first you have to understand what is an insulator. Insulator purpose, especially in outdoor system, it serves as a two purpose. First, it will support the transmission line as you see in the figure. Most of the outdoor insulation or outdoor insulators, it serves two purpose, supports the transmission line. Second purpose would be provide enough isolation between tower and conductor. I repeat, provides enough insulation or isolation between tower and conductor. So any outdoor insulation, any outdoor insulators, these two is a must characteristics it should have. Right now, what is the major problem we are facing in India is a problem called pollution flashover. We are facing a major problem called pollution flashover. And if you are not aware, I'm just telling, pollution flashover happened in India 2002, 2003, 2008, including 2012 it happened. When it happened, around 18 states in India, the total power got destroyed. 18 states were without any power, the trains were stopping then and there, no backup, nothing. What happened? Government formed a committee on that. Why it has happened? They found that pollution flashover is the reason behind that. It's also available in CEA report. Why it has happened? As I told, the purpose of any insulator is to support the conductor and to provide any electrical isolation between tower and conductor. When the external pollutant accumulate on the surface of the insulator, the insulating property is subsided by the contaminants. These contaminants under the dry condition, it won't conduct. However, when the atmosphere is wet, enough moisture is there, then leakage current will flow, and this leakage current eventually results in the scintillation, and the scintillation leads to flashover. What are the contaminant sources? Is one is bird dropping. Bird shit is one of the major pollutant reason. Second is burning of agricultural waste near the transmission towers. Third is industrial pollution, having a high pollutant source within the 3 kilometer radius of the transmission towers. And if your transmission line is near this issue, even the salt content in the air will result in the contaminant accumulation on the insulator surface. Since India is a peninsular country, all the three states we are covered with water, seawater especially. So India is more prone to coastal pollution as well. The criticality about pollution flashover is you cannot nullify the pollution flashover unless and until either you reduce the voltage or change the insulator. And it's literally suicidal to cut off the supply because again there is no use on that, and you cannot change the insulator in the tower just like that. It's a huge manual process. Actually, what you are seeing is experiment simulated in the laboratory of CPRI. What we have done here is this is a post insulator. We have covered the post insulator with the contaminant, and you can see some white moisture, white surface around that. It is the air mist. We created an artificial fog. Then we supplied the voltage. What is happening right now is since the contaminants are already there on the surface of the insulator and moisture is there to wet the contaminants, first scintillation starts. That is a small arc what you have seen before the total flashover. Then this small arc builds on to form a bigger arc. Technically scintillation crosses 2 by 3rd of the insulator length, it will goes to flashover mode. So this process, if the flashover happen, huge amount of heat will be generated and huge amount of power loss will be there. And the worst part is the power transmission in the line cannot be reactivated unless and until you clear the fault. That is the even more worse part. And this is not a very much rare problem. It happened in India around 18 states in 2002, then repeated in 2003, then 2008 and 2012 as well. So what the government of India has done is they formed CA, of course CA formed the committee. One of the suggestion they have done is find the pollution map with reference to transmission system in India. So what PGCL and CPRI together did is they formed a committee of researchers. I was also one of the team member on the project. We literally measured every transmission line in India. We went to every transmission towers in India. We measured what is the pollution level on the tower for 2 years. Why we would measure for 2 years is suppose if you go to a tower and there was a rain before that, obviously the pollution level will be very low. So we measured pollution level for 2 years in every high voltage tower. The moment I say high voltage tower, it will be 220 kV, 400 kV and 750 kV transmission lines. We measured in every transmission line what is the pollution level in India. We had created, not government of India created pollution map for every towers in every state, in every district. Right now, India is one of the few countries to have actual pollution map for every region where the transmission line passes. And according to the pollution level in the atmosphere, we will select the insulator for the particular tower. I'm moving for the next slide. So immediately to avoid the pollution problem, one of the methods Indian power system employed is helipad cleaning. What you are seeing in the first picture, we used to spray water with a high velocity on the surface of the insulator. The first picture, that's what it depicts. India also did its own helipad cleaning. especially in northeastern and northern states. And wherever substation is there, we tried hotline washing. What is happening in the second picture, it is called hotline washing in the substation. What the person he is doing is he's spraying the water with high velocity on the substation insulator. First picture speaks about the transmission line insulator. This two process immediately we can do to rectify pollution flashover, but this is not a long-term objective. Only for short term, this might able to cure the pollution flashover, not definitely for long term. First, you should know what are the insulators used in the transmission line. In India, generally three types of insulator are used in the transmission line. One insulator is porcelain. Yeah, porcelain includes ceramic and glass insulator. So if you want in detail, there will be three insulators: ceramic insulator, glass insulator, and polymeric insulator. These three insulators have been used widely in India. And out of the three, 80 to 90% of the insulator used in India right now is porcelain or ceramic insulator. Right now, ceramic insulators are being replaced by polymeric insulator. Most of the new line being ejected comprises of only polymeric insulator. Why polymeric insulator is to avoid pollution flashover. I will come to that later. Why I have included only two research areas for porcelain insulator, that is ceramic insulators. We have been using ceramic insulators for past 100 to 150 years. So most of the research area on that is done. Most of the standards are very much standardized when it comes to porcelain insulator. So if you have at the undergraduate level as a PhD scholar, if you postgraduate scholar, if you want to do research on ceramic insulator, there are few areas which are not yet been completely solved. One is, even though India has pollution map for its entire region, we have not done cost benefit analysis for which level of pollution level, which level of insulator we have to choose, and what about the cost benefit analysis for that particular level of insulator. That study is not at study is little bit available, not in a wide area. It has not covered. So those who want to do research on that particular porcelain insulator, if you want to do, you can do cost benefit analysis. And also the corona ring is another important term. Right now, corona ring, especially in terms of polymer insulator and porcelain insulator, different corona rings are available. Corona, I believe you know that. What is corona? Corona means the sustained discharges happening at the sharp edges of the conductor. Corona means sustained discharge happening on the sharp edges on the conductor. So to avoid this corona and to avoid the electrical stress are building around the insulator, we used to have corona rings surrounding the insulators. And these corona rings, the different types we are using a half-sleeved, full-sleeved ones. And this research is still there. If you want to do research on this area, this possibility is still available for you. I'm moving for the next slide. This is a general picture how the arc builds around the insulator and how the flashover will happen. If you see the first two pictures, the flashover is happening on the surface of the insulator. There is no jumping here. However, if you see here, flashover is happening in the air gap. So this particular flashover is called flashover happening around the leakage length, and this is called arc length flashover. This is happening mostly in the air gap. I'm moving for the next slide. So to avoid the problems of pollution flashover, which is more and more prevalent at the ceramic and glass insulator, polymer insulator comes into picture. Polymer insulator primary property is hydrophobic property. I repeat, polymer insulator's primary property is hydrophobic property. It is similar to what you are seeing in a lotus leaf. In a lotus leaf, if you pour water, water cannot just flow, it will form a water globule. As shown in the first picture. If water cannot flow and water can only form water globule, then even though contaminants are there in the insulator, water cannot flow, water can only form globule, then leakage current cannot happen, And if the leakage current cannot happen, scintillation possibility is nullified. That is why right now, wherever high pollution is there, India is moving for composite insulator. Composite insulator, another name is polymer insulator. So I'll be using polymer insulator and composite insulator name vice versa. So right now, one of the easiest solution to avoid pollution flashover is when you are erecting a transmission line, go for polymer insulator directly. However, there are certain disadvantages in that too. One of the disadvantage there is polymer insulator is made up of organic material. It is made up of silicon. Okay, it is made up of silicon insulating material. Polymer insulator material made up of organic. The moment it is made up of organic, it is subjected to electrical stress, mechanical stress. It is subjected to degradation, ultraviolet degradation. It is possible. When the corona is happening, again, structural damage might occur. So these are, with the moment you are erecting a composite insulator, it is mandatory that you have corona ring on the top and bottom of the composite insulator. Since it is made up of organic, it is subjected to more and more dielectric stress as well as mechanical stress here. So right now we don't have any standard for composite insulator. I repeat, we have 100-year experience in porcelain insulators, but the experience we are having as a power engineer on composite insulator is only for last 25 years to 30 years we are using this composite insulator. So there is not many standards yet available for polymeric insulator. Those who want to do undergraduate research or postgraduate or PhD, you can start your research with polymer insulator because there is no standard available. The moment I say there is no standard available, it means there is a huge opportunity for researchers to do research on that. So you can also bring your own standard if you could able to achieve the results. So right now, wherever the new line is being erected, we are using composite insulator. What about the erected line already? What about the line which is already been mounted and in service? There, what we are doing is we are covering the surface of the porcelain insulator using coating techniques. What you are seeing in these two pictures is a person is coating RTV. RTV means room temperature vulcanized coating. Room temperature vulcanized silicon coating. He is coating silicon material on the porcelain ceramic insulator so that he can impart hydrophobic property on the surface of ceramic insulator. That is the idea. So wherever pollution is right now happening and we can't change the entire insulating structures, we are making sure that it is pollution free by means of coating the ceramic insulator surface with RTV insulating material. So right now this is for, we are doing both RTV coating as well as replacing the ceramic insulator with polymeric insulator. And again, what about the thickness of the coating? What about the distance? How much thickness I should do? That standardization is not yet available in India. Not only in India, in the entire world, it is not available. So since standards are not available for this particular process, you can do all the mentioned research here. You can do aging analysis. As I told earlier, polymeric insulators are made up of organic material. They are prone to aging. So you can do aging over a period of 100 hours, 1000 hours. When the mechanical load and electrical load is applied, what about the aging, whether it is amplified or it is subsided? When the moisture is there, when the moisture is reduced, what about the aging? There are recommendations in the standard right now, but there is no clear-cut output on that. And what about the composition? Even though I say it is made up of silicon material, silicon along with the filler material, alumina filler should be there for composite material. How much silica should be there? How much filler should be there? Still not yet clarified. And those who have done on that area, they hold the patents and they are making the products. So this composition is one of the area you can do the research. And what about the influence of electric field on the water globule? It has been found. We know that the water globule is there. When the electrical stress is there, the water globule tend to move on the surface of the insulator. And how much it is being affected by means of electric field you can do. And the RTV coating, we have no idea. Right now, standard says 0.5 mm to 1 mm. Certain times in centimeter level also it is required. How much thickness it is required, still an area of concern. And what about half coated? As I mentioned in the earlier picture here, we are coating the insulator, entire insulator using RTV coating. Certain times they will use coating only for the bottom of the insulator, especially overhead cap and pin insulators, than on the top of the insulator. At that time, what is the pollution performance? This bottom coated or off coated insulators, they are cost effective. What about their pollution performance is yet to study. And you can see the field analysis, how this electrical stress is actually affecting the aging of polymeric insulator. That area is still to be done. I just given the pictures for you for your better understanding. What you are seeing in the first picture is a polymeric insulator and water globules of when the water is sprayed, water is not flowing on the polymeric insulator surface. Instead, it is just forming a water globule. And next, what I'm trying to do is I'm covering the entire insulator with pollutant. That's why it is in brown color. Why I'm covering the entire insulator with pollutant is when I cover the entire insulator with pollutant material, to how much extent this water hydrophobic characteristics can be transferred from the surface of the insulator over the pollutant. That study is being carried out. That's why I have given this particular picture for you. I repeat, why I have covered the insulator with the pollutant is I want to see to how much thickness of the pollution my hydrophobic characteristics can be transferred above its known value. That's I want to study. And here what you are seeing is this gray area is nothing but a RTV coated insulator. The gray area what I am showing in the screen is the RTV coated insulator. I am applying a 6 kV voltage here. I repeat, I am applying a 6 kV voltage and the water is salted water. The water is a salted or conductive water for you. And I am seeing when the conductive water is there, when the voltage is there across the insulator, whether flashover is happening or not, and if the flashover is happening, whether my surface can able to withstand the discharge or not. This particular technique is called inclined plane tracking. What you are seeing in the picture, it is called inclined plane tracking. This technique is still to be, lot of things are there. This technique will help you to analyze what is the different thickness we can coat our ceramic insulator with RTV, how far it is aging for a different thickness as well as with a different composition. That those criteria is not yet well established. Those who want to research, this is one of the area you can do, and the source voltage is only 6 volt. You can get within your college. If you get any funding, it is easy to build and it's a wonderful area to analyze. And in recent time, even the bushings, including the transformer bushing and the wall bushing, we are moving for polymeric insulators. Earlier days, we are using only ceramic or porcelain insulator as a wall bushing and bushing for the transformer. Nowadays, that is not the case. So the moment polymeric insulator comes into picture, it means it cannot take more and more heat on the surface. It is subjected to thermal degradation. So how the polymeric insulator behaves under different temperature and how much heat it can sustain for a longer period of time. And the critical part when it comes to substation heating of the equipment is the heating will substantially reduce when the wind velocity is more. So if you see in the first picture, even the load is constant for both the both the pictures, the load is constant. However, when the wind is flowing at 15 miles, you can see the temperature is around 30 degree, 24 degree and 22 degree on the bushing side. However, when the wind is not there, you can see there is a sudden rise in surge in the temperature. 30 degree heated bushing turns out to be a 47 degree heated bushing. So this phenomena is very much critical whenever you are using both ceramic as well as polymeric insulators. So this study also you can carry out. If you want, those are the areas for outdoor installations. And there is another interesting area happening. It is called the pulsed electric field. Pulsed electric field means you are applying electrical power in a pulsed manner for a very short time. That is called the pulsed electric power. For example, in terms of microseconds and milliseconds, you apply high voltage pulses for your needs. Why we need this pulsed electric field is for processing techniques nowadays people are using food processing technique. For example, if you want to have a juice without any preservatives on it, one way of having do preservative free juices to make sure that you apply pulsed electric field on the juice. This is one of the research happening when it comes to commercialization of electrical power. So major research is happening in this area where people don't want any artificial preservatives in their food. They want to have the food as it is, and they don't want any chemicals in the food. Right now, extreme research is happening in this liquid food. Actually, I have shown the picture of fish and meat, but as per my understanding, in liquid foods, this growth on this particular research area is happening much. Especially in Anna University, there is a professor. She is doing much research, especially on pulsed electric field. Cancer treatment also, we are trying to apply the pulsed electric field. We would try to apply the electrical power to the cells for a very short period of time, and which since the cancer cells are already of very weak stability, when you apply the lower voltage, it will break down. So you can reduce the amount of chemo you are giving to the patients. Defense technology we are using. For example, missiles and bombs. It won't just switch. If you switch on the switch, it won't actually blast. We are applying high voltage pulses in the detonation segment so that the bomb can ignite. That technology is still very much applicable in defense, pulsed electric field, and even in water recycling. If there is any much of wastewater is collected, we are trying to create flashover within the water, and when the such flashover happen within the water, all the microbial activity within the water get eradicated, and that water can be used. This is particularly useful for defense also. When the defense personnel are there in the extreme location where they can't get access for water as much as possible, so even though wastewater they have collected, they can try to apply the pulse electric field to recycle the water and use for their own welfare. These were the four such areas still happening, very much happening. What you are seeing in this picture is the girls are holding a pulse forming network. They are my students. They are holding a pulse forming network up to 9 kV capacity. So we could able to create a pulse forming network which can give a 9 kV output voltage for 1 microsecond time. We can able to do that. We had done with the help of Dr.S.Sudalai Shunmugam. He is a former colleague of Abdul Kalam as well, from Xeonix, Bangalore. They funded the project. So if you want to work on this public, so if you want to see how the technology is used for public welfare, you can work on pulsed electric field. It's a bit of cross stream. You should know what is electric field, and you should know also what is the mechanism of foods. So you should know more about engineering as well as science. And another interesting area happening in the power engineering sector is transformer oil replacement. I believe you know that transformer oil is used in the transformer for insulation as well as for cooling purpose. And right now, most of the transformer oil we are using as a derivative from mineral oil, and this mineral oil are non-decayable. They cause much harm to the atmosphere, and wherever this oil is spilled, nothing can grow for hundreds of years. It is poisonous as well. Still, we are using in all the transformer. The reason being we don't have any alternative. Last 20 years, this research started as well. We are trying to replace the existing mineral oil with vegetable oil, synthetic oil, sometimes by mixed distillate fluid. This research is still on the budding stage, I would say, because even though we found that certain vegetable oils can be used as a insulating fluid for transformer, we are using so far only for the distribution level. We have not used any alternate insulating fluid on the power transformer level, at least as far as my understanding goes. We have not found an exact alternate vegetable oil which can be directly used for power transformer, and power transformer is one of the costliest equipment in the entire power system. We can't afford any fault in those power transformer. So there is a huge opportunity if you want to do any replacement of dielectrics. You do if you want any very much environment friendly alternating insulating fluid, those research is still there. You can concentrate on physical property, electrical property, and chemical property. What kind of oil it is, how much it is, what is the freezing point, what is the flash point, what is the fire point, how much it is interacting with the rest of the material within the transformer, and most importantly, what is the breakdown strength. You can do those analysis, and this particular property, whatever I'm mentioning, it will change according to the transformer you're considering. For example, if you are using the transformer at the distribution level, the faults occurring at the distribution level is quite different when compared to the fault occurring at the power transformer level. So that fault you have to study first and then come back to here. It is imperative that you have to do that first. And another interesting area right now happening is applying AI technique in power system. One of the area where you can easily apply AI technique is collect the dissolved gas analysis data. Dissolved gas analysis means whenever fault is happening on the transformer, it will create some kind of gases within the insulating fluid. If you can able to extract the gases in the insulating fluid, from the gas level you can identify what type of fault might have occurred in the transformer. That analysis is called dissolved gas analysis. There are a couple of standards is there. IEC standard is available, dual triangle is available. However, there are still lacunas where this standard is miss something, that standard will miss something. For that, people are trying to apply AI technique, including all the functions of both the standards and if at all another couple of standards, and find an exact system where wherever the gas, whatever the gas ratio you give, it could able to identify the fault. This process is still available. This research area is wide open, and if you could able to do that, you can assess the internal condition of the transformer, when it should be rectified, what kind of fault it is. You can able to see avoid long-term failure of the transformer, and if you could do even more better, probability of failure also you can assess very much keenly and clearly. Uh, I think I have covered the. I have another 8 minutes, I believe so. If you have any doubt, you can please put a question. I'll be happy to answer. Or if you want to revisit any particular pages, I'll scroll back and answer. I'm open to questions.
Sir,
Yeah.
which type of insulators used in other countries?
Okay. If you are speaking about India, it is ceramic insulator. If you go for Italy, we are using glass insulator.
Okay, sir.
If you go for Europe, they are using long rod insulator. If you go for US, they are using cap and pin insulators. The way Italy is using glass insulator is their soil has more amount of quartz.
Okay,
That
sir.
is the simplest way. In India, the soil is, if you as you can see, soil is mostly reddish. The reason it is reddish is because silicon content is there. So India soil is almost all reddish. So we are using ceramic insulator. That is the simplest answer.
Cost wise is different, sir.
Ceramic insulator and glass insulator costs are almost equal.
Okay, sir.
Polymer insulator is way lower. For example,
Okay.
220 kV line, ceramic insulator will cost 25,000.
Okay,
Polymer
sir.
insulator will cost 6,000. If you import from China, if you made in India, it is 15,000. It will come. That is why, to add that question, I will give another clarification for you. To avoid the dumping of product from China, government has increased the tax from Chinese suppliers, so
Okay,
that
sir.
we can protect our Indian suppliers.
Thanks.
As I was speaking about Anna University, there is a professor, Dr. Gauri. She is doing much research on pulse electric field. If you go to Anna University, try to visit her lab. She built an expensive lab for pulse electric field application. And recently, Anna University came into an agreement with Purdue University, USA. Both the universities are exchanging. Anna University Chennai campus and Purdue University, USA. They are exchanging students only to study pulse electric field applications. And I believe Professor Sarathi from IIT Madras is also doing research on polyplastic.
Any queries?
Sorry. Sorry, in second slide, you mentioned the WG committee.
Yeah,
May I know what do you mean by WG committee, sir?
WG means Working Group Committee. WG stands for Working Group Committee. For example, you belongs to what department you belongs to?
I am belongs to mechatronics engineering, sir.
Mechatronics engineering. Sir. Suppose mechatronics engineering, any particular problem is there. First, they will find a task force on that.
Yes,
Mechatronics
sir.
is a huge area. Mechanical and electronics both comes into that. On
Yes.
entire mechatronics area, any for specific topic, they will form a task force where the problem is there. The idea of task force is where is the problem and why it is being caused. And once they are sure that there is a problem, then more scientists will work on that problem and they'll give the detailed description of the problem. Particularly, for example, mechatronics plays a huge role in satellite ejection, building of satellites on that mobile mechatronics on its direction conversion, especially on satellite direction conversion. Mechatronics plays a huge role. Suppose then they will analyze only on that area where the problem happened, why it is happened. It will give the entire picture. Suppose a problem arises, they will speak when is the year, what is the year of problem, why it has happened only in this particular area, what are the parameters which actually caused this effect. These analysis will come from the working group committee. So if you are a mechatronic person, it's your duty to right now to find what is the working group working on, what working group is working on which type of problem right in mechatronics. The moment you know that, you know what is happening in your field. This simple as that.
Okay. Thank you, sir. Thank you.
Yeah, please, anytime. Those who are interested in algorithm right now, the entire power engineering, we are trying to apply different algorithms, especially game theory, different approach, graph theory. We are trying to find by means of which approach we can have a reduced power loss, which approach we can see, which type of line we can choose. We are trying to move more and more towards analytical and programming. Even the substations nowadays it is not manually maintained. If you don't know, please understand that entire substation we are recording the digital recordings. We are transferring the digital recordings to the source station where it is decoded, and from the decoded message we are trying to analyze what is the status on the substation, and according to that we are doing annual maintenance. India is moving in that way and the world is moving in that
Thank you, sir.
way. All right.
That
Thank you.
that was an awesome presentation. Give thanks for a little, and you will find a lot. Honorable Chairman, Managing Director, and respected General Manager Development, it's my privilege to have been asked to propose the vote of Department and Alumni Association. I extend a hearty rate of thanks to the Honorable delegates who blessed us with their presence and took a valuable time of your busy schedule. I must mention our deep sense of appreciation to Mr. Vignesh for his work. Also, I would like to extend a special thanks to Dr. Sudalai Shunmugam. We know how busy you are, so we are grateful that you take the time to prepare and spend on evening with us. Your talk was particularly appropriate. It really triggered us for initiative, new ideas and thoughts. I would like to express my gratitude to our principal, Dr. Vail Murugan, for providing encouragement and support. And I am very grateful to Dr. P. Annapandi for giving us an opportunity to organizing this event. I am very grateful to Mr. S. Krishna Kumar for supporting us to conducting this event in a grand success. I heartily congratulate to all the participants and alumni of FXEC to participate in this event, as no program can become successful with a single person. So I extend my big thanks to our Supply Department faculty for the support.
Thank you all for settling and for your feedback.
Dr. How are you?
Sir, Kumar sir is in line, sir.
Hello, Dr. Sudalai.
Hello, sir. How are you?
Very fine, thanks.
Nice to meet you, sir. It's been a while.
Our wonderful presentation from Bangalore chapter, and it's
Thank you, sir.
wonderful. Thank you for your support.
Glad to be here. Glad to be here.
Thank you. Thank you.
Sudalai, nice to meet you, Sudalai.
Pleasure to meet you. A pleasure.
Okay, your session was awesome.
Oh, thank you, sir.
Thank you so much for coming and conducting.
Anytime, sir. Anytime.
Okay, and our love and regards to all at home. All the very best. God bless.
Thank you, sir. Thank you, sir.
Take care. Bye.